Hey students, Ms. Tiedemann here. We're looking at section 7.5, which is all about possible solutions to quadratics. Remember, our focus is quadratics. So everything we're doing right now is dealing with something with x times x or x squared of some sort. Quadratics all look like parabolas. Okay, so these are just refreshers, hopefully, for you guys. Remember, quadratics can be written in three forms: factored form, standard form, and vertex form. Okay, so let's have this is kind of a repeat, but I think it's really worth it because you guys really need to know how to do this. I haven't emphasized enough, but this unit and last unit are vital for you guys to be successful in Algebra 2, and all y'all are going to Algebra 2. So make sure that this is what you're paying attention to, because this will come back, okay, twofold. All right, so it says find all the solutions to x plus 5 times 2x minus 3 equals 0. Kicker here to notice, okay, it says it equals 0, so that's our win. So that means I'm looking for when each one of these equals 0. Okay, now you guys are usually really good with these ones. Okay, you can do these mentally. What plus 5 is 0? Okay, negative 5. Negative 5 plus 5 is 0. Now, the issue is usually the second one. All right, so remember what you're really doing with the first one is you're really setting it equal to 0 and solving it. Okay, because if you subtract 5 from both sides, you get x equals negative 5. Okay, that's ultimately mathematically where this comes from. Okay, do I think you need to do all of that for those? No, because you can do these mentally. However, I do think you need to do that for these ones when there's a coefficient. Remember, a coefficient is the number in front of the x, so that 2 there, right? So in this case, when you're solving this, you're just setting this equal to 0 and solving. So what would I move first? I would add the 3 to both sides. So then I'll have 2x equals 3. And then to get rid of the 2, I'm just going to divide by 2. So x equals 3/2. Okay, or if you have fraction phobia, okay, that's 1.5. Okay. I prefer that it's written in fraction format, but again, there's no difference between 3/2 and 1.5. Okay. This rule is called the zero product property. Okay, a zero product property means if you have something equal to 0, that means one of the factors is 0, because anything times 0 is 0. Okay. Okay, let's look at some other types of equations. All right. So 3 is the only solution to x squared minus 9. All right. Well, we do know that if we were to plug 3 in, 3 squared minus 9 equals 0. Let's check it out. So 3 squared is 3 times 3. That is 9. 9 minus 9 is 0. Okay. It is a solution, but is it the only solution? Okay, I would caution you on this, because if you were to solve this, your first step would be to add 9 to both sides. Okay, so then you get x squared equals 9. From here, the opposite of a square is a square root. Okay, this is where I would square root both sides. Anytime that I draw the square root, okay, again, anytime I draw the square root, that means I get a plus or minus answer, okay? Meaning that you're going to have x equals, okay, because these cancel, x equals plus or minus square root of 9. Well, the square root of 9, okay, is 3. So my answer is x equals plus or minus 3. So meaning it's 3 and negative 3. Now that makes sense because 3 we already found works. Negative 3 does the same. okay? Because if you plug in -3, okay, -3 squared minus 9, -3 times -3 is also 9. 9 minus 9 is 0. So you have to be careful about whether there's negatives or not. And again, if you write the square root, that is where the plus or minus comes from. Okay. If the square root is already written, that is not the case. So my answer here would be false. Okay. It is not the only solution. All right. A solution to x squared plus 25 is -5. Well, let's just solve it, see what happens. Okay. So here you'll have x squared plus 25 equals 0. Move the 25 to the other side. So x squared equals -25. From here, we have ourselves a problem. Okay. Anything squared, okay, we've talked about this. Some of you may have forgotten. Okay. It is what it is. Anything squared is positive. Okay. A positive times a positive is a positive. Okay. A negative times a negative is also a positive. So this, okay, is never going to happen. So my answer here, I would just say is false because there are no solutions to this. Okay, if I were to write anything, I would say no solutions to this equation. Okay, because there's never going to be a place where that happens. All right, x times x minus 7 has two solutions. All right, let's talk about this one. This is zero product property, okay, because again, we're equal to 0. So this is when I want to look at both pieces and see when they equal 0. So when does x equal 0 and when does x minus 7 equal 0 is what that's saying. Well, there's one solution, okay, and then here's your other one. That would be 7, okay, because 7 minus 7 is 0. So does it have two solutions? Yes. Yes, it sure does. In this case, true. It has two solutions. All right, now I'm asking, are 5 and -7 solutions? Some of you, if you look at this equation, you'll be like, well, yeah, it does. Okay, because you'll look at the way that we looked at the last problem and you'll see this and you'll be like, yeah, that would be 5. 5 minus 5, 0. And then you'll be like, -7. That would work too. Okay, that would be true if it equaled 0. Okay, but what does it equal here? In this equation, this equals 12. So no, the only time that you can do that where you're looking at those two equations and setting them equal to 0 is if the equation equals 0. So you cannot do that in this circumstance because of that 12. Okay, so we're going to look at solving quadratics today by graphing. And just kind of looking at scenarios where solving quadratics would in different circumstances. But we are going to be looking at a little bit with graphing today, okay? So Han is solving 3 equations by graphing. Notice how all of them on the left side are the same. You have x minus 5 times x minus 3. The first one equals 0. The second one equals -1. And the third one down there equals -4. It says to solve the first equation, x minus 5 times x minus 3 equals 0, he graphed it. And then he looked for the x-intercepts on the graph. Explain why the x-intercepts can be used to solve that. Okay. In this case, you guys, x-intercepts are zeros. Okay, that's the same thing. X-intercepts are zeros. Okay. Oh, that is not how I spell. Well, apparently that's how I spell, but that's not how you're supposed to spell. Which is true. X-intercepts, okay, are our answers. When the equation equals 0, okay. Again, that's the kicker, is it has to equal 0 in order for them to be x-intercepts, okay? Because x-intercepts, remember, are when y is 0, because this is your x-axis, okay? And that means you didn't move up and down at all on your y-axis, so the y is 0, okay? And that's the circumstance here. Next slide will show you the graph, okay? So here's the graph of his equation. So he graphed x minus 5 times x minus 3. Now again, you don't write, if you guys are in Desmos, you don't put equals to 0, okay? You just write the equation. And in this case, he'd be looking for those zeros, okay? And they're right here and right here. Okay, so my solutions are 3 and 5. I could have figured that out without a graph, because in this case, 5 minus 5 is 0, 3 minus 3 is 0. Okay, so I knew it was going to be 3 and 5 anyways, but again, you can see that graphically because this is where it's crossing the x-axis, because again, it equals 0. Okay. It needs to be equal to 0 if you are looking at the x-axis. Okay. Now, do you always have to look at the x-axis? No. Okay, but that's what you're looking for if that's the case. Okay, so let's look at the next scenario. So now, okay, Han again says he's solving the problem. Okay, second part, he says to solve the second equation, he wrote x minus 5 times x minus 3 plus 1 equals 0. Okay, so what he did there is he took this 1 and put it on the other side of the equation, which is great because now, again, he's looking at it equal to 0. So we're looking at the x-axis, okay? How many solutions are there? In this case, how many times does it cross? Okay, it doesn't cross at all, but it does touch. So there's only one solution in this circumstance. Okay, now what is the solution is the next question. Okay, and that solution is where is it happening? And in this case, we'd say at 4. The solution is 4. It's not asking about a point. Okay, you guys, when it's saying what is the solution to the equation, I'm asking you what does x equal? And in this case, x equals 4. All right, so let's look at the third circumstance. Okay, so let's use his same strategy. So if we're going to graph this, okay, we would have our parentheses x minus 5, and then x minus 3. Okay, and in this case, we're moving the 4 over. So we would put plus 4. I forgot in the front, I need to have y equals. Submit. Okay, so there's my graph. Okay, so there's the graph of that third equation. So remember it equals 0 now, okay, because I set it equal to 0. So I'm looking for when does it cross the x-axis. So in this case, I'm looking when does it cross down here? Okay, where is this happening? Never, okay. It doesn't cross down there. So I'd say no solution. Okay, it's not crossing that axis at all. Okay, so there would be no solution here. Okay, so still same circumstance here, okay? So he's saying, thinking about the strategy used and the solutions you found, why might it be helpful to rearrange the equation equals 0 on one side and then graph the equation on the non-zero side? Well, then it has everything on one side for you. I guess that's kind of what we're looking for, because what they're saying is you can't assume you know the answer because this one had 2 solutions, this one had 1 solution, this had 0 solutions. So again, if we have it equal to 0, then we're looking at just the x-axis. Okay, you're looking for the x-intercepts. And that makes it consistent. So if it's equal to 0, I'm like, okay, I know I'm looking for the x-intercepts, rather than searching somewhere else on the graph depending on the circumstance, because that can get complicated. If you're constantly looking for some other place on the graph, it can be very confusing at what you're actually looking for. Okay, and what I'll explain for is that in this problem right here. Okay, so here, these are your 3 graphs. Okay, so these are the first, second, and third graph. Okay, as they equal to 0. Okay, he graphed those 3. So those are the 3 graphs we've already seen. Okay, so remember, I'm looking, the number of solutions deals with how many times it's crossing the x-axis. Okay, so then I'm only looking at the x-axis and the x-axis only. So it's helpful when they're equal to 0 because then I'm only looking at one place. Okay, so I know that if I'm looking at the red graph, okay, that crosses twice. So that has 2 solutions. Okay, and then when I look at the blue graph, it crosses once. So that has 1 solution. And then if I go back and I look at the green graph, that never crosses the x-axis. So I know that that has no solutions. Okay, so it's helpful when we're equal to 0 because then I'm only looking at the x-intercepts. Okay, are the original equations and the rewritten equations equivalent? Absolutely. You guys, we didn't do anything other than move it to the other side. So equivalent means they're the same. Yes, if I add 1 to both sides of an equation, same thing. Why might it be helpful? Okay, we already talked about this. All right, what equation would you graph to solve this? Okay, so if I were to graph this, okay, I would take this and I would graph x minus 4, oh, sorry, y equals x minus 4, x minus 6, minus 15. Okay, because remember, I want this to equal to 0. That is what I would put on a graphing calculator, okay, Desmos, and that would be what I would write. Okay, so in this case, what would I change? Okay, I need this equal to 0. So I would take, I would subtract the 5 from both sides. So I'd have this equal to 0. Okay, I didn't touch that x plus 3 squared, but I need to combine these. And that would become -6. -1 minus 5 is -6. Now, if you're like, well, I don't remember how to do that. If you plug this in your calculator, you do -1 minus 5. Okay, and you graphed that, okay, as your y equals, that's going to do it too. Okay, because your graphing calculator is smart enough to do that. So if you're having a hard time combining that or knowing why don't I put it on the inside, okay, you can write it like that. It's not going to make any difference. All right, so let's look at some solving questions. Okay, and let's some of these you might need to graph, some of these we don't really have to. Okay, when you have an x squared by itself, okay, you shouldn't need to graph these, okay, because this is just very mathematically, the steps for this is pretty easy. So from here, I have x squared equals 121. So I'm just going to square root both sides to get rid of the square. Now, again, I wrote the square root. And anytime I write it, I get the plus or minus. So my answer is x equals plus or minus square root of 121. Now, if you don't know what the square root of 121 is, do it in your calculator and see if you get a whole number. If you get a whole number, write the whole number. If you don't, leave it as a square root, or what we call them as radicals. This one, the square root of 121 is 11. Okay, if you do that into a calculator, that's what you're going to get. Okay, Don't tell me you don't have a calculator because you have one and you're also looking at a computer. So I'm assuming you have a calculator there too. So your answers are 11 and negative 11. Those would be your two answers here. Again, when you have x squared and no other x term, that's the approach you should be taking, is taking that square root. All right, so this one, same approach, okay? Because do we have any x terms? So we just need to take x squareds. So from here, we're gonna add 31 to both sides. So I get x squared equals 36, okay? And then we're gonna get rid of the square. So I'm gonna square root both sides. I wrote the square root. Since I wrote the square root, my answer is plus or minus. And then I try to do the square root of 36 in my calculator and I get 6. So my answers are 6 and negative 6. Okay, again, I can take the square root approach when there's no x term. All right, we have zero product property. You see how this is equal to 0? Okay. If this is equal to 0, which what we have here, we're just looking for when each one of those equals to 0. Okay, and in this case, that would be 4, because 4 minus 4, 0. And 4 minus 4 is 0. So you really only have one solution here. Okay, in this case, just 4. I mean, if you wanted to write 4 twice, be my guest, but 4 is only going to happen once on the graph. Okay. And when this happens, what's happening graphically is this is going to hit 4 and touch back. Okay, so you're going to, it's what we call kind of a bounce. Okay, it's not going to go through the x-axis. It's just going to touch the 4 and come back up. Okay, now this one we cannot solve with our zero product property. We can't use our square root method, so we're going to have to graph this one. So if I move the 5 over, then it'll be equal to 0, and I can graph it. Okay, so hold the phone. I'm about to show you how to graph here. So let me share. X plus 3, x minus 1, x minus 5. Okay, so in Desmos, we get a graphing calculator. Just go to desmos.com. So from here, you would type in x plus 3, x plus 5, sorry, minus. Okay, I need to go back to that slide. No, wrong spot. Sorry, you guys. Okay, here it is. So x plus 3, x minus 1. Okay, this is now not moving. Okay. X plus 3, x minus 1. Minus 5. Okay, so here it is in a graph. Now, if you guys didn't know this, okay, and you should because we've done stuff with Desmos before, off on this right-hand side, you can zoom out a little bit, okay, so you can see more of the graph. So because I already set this equal to 0, I'm really looking for the x-intercept. So there's one right here, okay, and that's at -4, okay, and then my other one here is at 2. So then if I were to put my answers, that'd be at 2, okay, and -4. Does it matter the order you put them in? No, never does. Okay, so don't ever hesitate on that one. It really doesn't matter. Okay, here, when you're looking at this solution, you should notice this piece right here. You see how it equals a negative and you have a square? Okay, from here, no solution. Okay, you can't ever have a square equal a negative. Okay, the only time that's going to happen is when there's an imaginary, and that doesn't, you guys don't learn about imaginary numbers till algebra 2. Okay, so sorry, I'm moving you. My back is hurting, leaning over right now. So in this case, this would be a no solution because nothing you square is going to give you a negative number either. Okay. All right, so this one graphically again. Okay, we don't know how to mathematically solve these yet. We're going to teach you that, but we're not there yet. So again, I would put this into Desmos. So I have x minus 4, x minus 1. And then I need to move that 900 over. So I'm going to have minus 990. Now, notice how you're like, where'd the graph go? Well, you just put in a very large number. Okay, and now if you look at your ranges, you're only going like 20 to 20. So we need to scroll out. Okay, now if you scroll out a lot, you're going to be able to see that this parabola is really big, but I'm only looking for the x-intercepts. So once I can see them on my graph, I really don't need to go out any further than that. So my answers looks like I have 34 is one of them, and the other one is right there at negative 29. Okay. So, sorry, negative 29 and 34. Okay, again, order doesn't matter. I don't care what order you write them in. All right. Okay. Consider this. Priya reasons. So you have x minus 5 times x plus 1 equals 7. She reasons that if this is true, that either x minus 5 equals 7 or x plus 1 equals 7. It's supposed to be an equals 2 sign right there. Okay, she doesn't have an equals 2 sign, it's supposed to be equals sign. No. Okay, this only works with zero product property. Okay, this is not, hi Owen. This is not how you do that. Okay, you have to have it equal to 0 before you can do that kind of method. If you solved it that way, you would, if you plugged in your answers when you were done, you would realize that that wasn't it. Okay, so again, no. Okay, that process only works when it equals 0. Okay, or we do what's called the zero product property. Okay. Consider x squared minus 10x equals 0. Diego says to solve, he can divide each side by x and get x minus 10 equals 0. So the solution is 10. Mai says, I wrote the expression on the left in factored form, which gave me x times x minus 10 equals 0, and ended up with 2 solutions. We 100% agree with Mai. You cannot divide by 0, or not divide by 0, okay? So in return, you can never divide by x because you don't know what x is. X could be a number, but x could also be 0. So you can never divide equations by x because you don't know if they are 0. And that is an illegal move in mathematics. Okay, so in this case, we would agree with Mai in factoring. Okay. How would you solve this solution? Same way that Mai solved it. Okay. What, this is zero product property, so you set each piece equal to 0. So your answers would be 0 and 250. Okay. Sorry, you guys, I'm on my computer now that I shared that Desmos screen, so I'm not writing on my iPad now. So in this case, remember this, when you set that equal to 0 is just 0. Okay, and here, what minus 250 is 0. 250. Now the only reason I can use that is because this equals 0, not some random number. Okay. If you choose to solve by graphing, is it necessary to rearrange first? No, you don't need to rearrange if this equals 0. Okay. And you would not graph the equal 0 part. You would just graph x times x minus 250. Remember, when you set it equal to 0, what you're solving is an actual line because it actually already solved the equation for you. And I think that's about okay. Can you use the zero product property here? No. What does this equal? 100, not 0. My answer to is no. Okay. If we were going to solve something when it equals 100, you move the 100 over and graph. Okay, we'll show you how to solve those for realsies without a graphing calculator. You could do that on a graphing calculator. Okay, last one, 2, 1, or none. Okay, those are your 3 options here for answers to a quadratic. My answer here is no, none, because you have an x squared equals a negative number. The second one gives me okay, notice how it equals 0. Okay, so that means I set each piece equal to 0. So this would be 0, and this would be -2. So that gives me 2 solutions here. Here, a lot of you will want to say 2 solutions, okay, because you know that you're setting each one of these equal to 0. However, if you solve it, what minus 3 equals 0? 3. What minus 3 equals 0? 3. So you found 3, you just found it twice. So this would only be 1 solution. Okay. I hope you guys have an awesome day. If you need help, you guys, please reach out to your teachers, email your teachers, come to your night Zooms, go to Student Success Center. But we hope you guys have a great day in whatever you're doing.